Jai Hind everyone. My name is Mamta Pant and I'm working as an assistant professor in IT department of Ajay Kumar Garg Engineering College, Ghaziabad. Today in this video, we are going to discuss a topic known as keys in DBMS. So let's get started. First of all, before the definition, before any concept, I want to understand you what is the concept of key, from where it is coming in the DBMS. Let's suppose I have a table. This is my table number 1. This table is given in my database. Okay, we have 3 columns and 4 rows in this table. Suppose someone says that I want this information. Some person says to me that I want this information. So I will say, okay, I will fetch column 2 information from the table number 1. This is very easy. Some other person says that I want this information. So I will say, yes, okay, I have all these information in column number 3. So I will fetch the information from the table 1 from column 3 and I will provide it to the user. But the problem is here, if someone says, provide me information of this, means some user wanted to fetch the information of a given row. But here the scenario is changed. In the previous section, I am fetching information from the column parts. This is the column 2, this is column 3. But now what user wanted to fetch information from the row side. And column has the name, so it is easier to access this information from the column name, like column 2 and column 3. But rows don't have any names. So we cannot fetch the information row wise because it does not have any name. So here the concept of keys arises in DBMS. With the help of keys, we can fetch the information row wise, tuple wise or record wise. So now how we can identify what is the value of key, what would be the value of key. So suppose someone says, give me the information where the value of column 2 is equals to C. Some person says that give me the information of that row where the value of column 2 is equals to C. Here value of C in column 2 at 2 different places. So user get confused. For which information I need to fetch from the table 1? For which C? This C or this one C? Now the same cases arise if someone says that fetch the information where the value of column 3 is Q. Now once again at column 3 Q is at 2 places, 2 different places. So it is also get confused for which Q user want the information, this Q or this Q. But when someone says that give me the information where the value of column 1 is equals to 3. Now if you look at the column 1, the value 3 exists only at a single place. So it is very easy to fetch the information where the value of column 1 is equals to 3. I can easily fetch this information. Why it is so easy when I am giving the value of column 1 to fetch the information from the table? Because all the values of column 1 is distinct and unique. All the values are distinct and unique. So each value exists only a single time. And if someone gives you the value of a unique value, so you can easily fetch out this. But in case of column 2 and column 3, both columns have redundant duplicate values. Here C is duplicate, here Q is duplicate. So the values from column 2 and column 3, with the help of column 3, we cannot fetch the value of the table of any row. But with the help of the value of column 1, we can fetch any row or any tuple. So we can say for this table, column 1 will work as key attribute. Now you understand, here the attribute column 1 will be act as the key. Now from this concept we can derive the key is the value of attribute with the help of which we can identify the uniquely identify the rest of the attributes. This is the concept of key. Now comes to the definition. Now this is the definition. What is key? Key is a set of attributes. It could be a single attribute or a set of attributes that can uniquely identify the tuples in a given relation. Now here we use a term attribute. What is the attributes? Attributes basically the properties of the attributes is the property of entity of an entity set. So, okay, so this is the concept of key. Key is a attribute with the help of which we can uniquely identify the rest of the tuples or attribute. Next, here we have different types of key in our DBMS, like super key, candidate key, alternate key, compound key, surrogate key, foreign key, primary key. Here, primary key, super key, these 10 keys we will discuss in this video. Super key, candidate key, primary key are the most important key from the point of view of the university exam, GATE exam and all. And all three are come only with their definitions. And most importantly, most important is your candidate key from the point of view of university exam and especially from the point of view of the GATE exams. Candidate key are very much important. So let's start it one by one. Take one example. Suppose this is our relation R having attributes A, B, C, D. We have 4 attributes in relation R and this is a functional dependency A to B, C given for this particular relation. Here I will revise you what is the functional dependency. Here this functional dependency means if you will give me the value of A, I will fetch the value of B and C with the help of value of A. This is the true meaning of functional dependency here. So now A will be the key. Let's check it. Okay. Now with I have value of A. It I already have. And with the help of A, I can fetch the value of B and C. Okay. So from this functional dependency, I can have the value of A, B and C. But in my relation, I have 4 attributes A, B, C and D. And with the help of this functional dependency, I can only fetch A, B, C. D cannot be derived from this functional dependency. So according to the definition of key is an attribute with the help of which I can find out rest of the attributes. So A cannot be key because it is unable to find out the value of B. Now take next example. Example number 2. Again, there is a relation given R with attributes A, B and C and D and 3 set of functional dependency. So let's check one by one. First, we will find the closure of A. Closures means all set of attributes we can identify with the help of these attributes. So I already have A, B and C and with the help of these attributes I can find the value of D. So with the help of A, B, C, can I fetch all remaining attributes of the relation R? Yes, with the help of this I can find all the attributes of relation R. So this is key. Next, find out the closure of AB. I already have A and B and with the help of AB, I can find out the value of C and D. So with the help of AB, I can find out the rest of the attributes. Yes. So AB is also a key. Next, now find out the closure of A. I already have A and with the help of A, I can find out the value of B, C and D. So A is also key? Yes, A is also a key. So here we have 3 keys, A, B, C, A, B and A. All 3 are keys. Now a term comes into the mind, super key. Okay, what is super key? So in DBMS, all 3 are key. Now next term comes into the topic is super key. Now what is super key? So to understand you the concept of key, I use the terminology key. But in DBMS, if someone says what is key, so you should ask which key you are talking about. Super key, candidate key, primary key. So key is not a keyword in the DBMS. It comes to the super key. Key is whichever you have studied till now regarding the keyword. I'm talking about the super key. Okay, so what is super key? A super key is a set of attributes that can identify each tuple uniquely in a given relation. Basically, whatever I've studied before, the definition of key is the definition of super key. Super key is a set of attributes with the help of which we can uniquely identify the rest of the tuple or all the attributes in a given relation. So basically, A, B, C are not key, they are super key. Why? Because with the help of which we can uniquely identify rest of the tuples. So ABC is also a super key, AB is also a super key, A is also a super key. This is the concept of super key. Now, there are some points. A super key is not restricted to have any specific number of attribute. In a super key, we have 1 attribute, 2 attribute, 3 attribute. For example, here we have 1 attribute in our super key, here we have 2 attribute, and here we have 3 attributes. So, there is no restriction, no limitations of the number of attribute we have in the super key. And next one is thus a super key may consist of any number of attributes. Here is a note point that all the attributes in a super key are definitely sufficient to identify each tuple uniquely, but all of them may not necessary. What does it mean? Let's back to here. Here we have 3 attribute. Okay. So in first super key A, B, C, with the help of these attributes, I can find out rest of the attributes. Now, jo we have studied note point is say that it is not compulsory that each of the attribute is necessary to find out the information. Means here we have not included C, but we are able to find out the information. So here we can say C is not that compulsory in the super key. Every attribute definitely sufficient, but may not be necessary. So here C is not necessary to find out all the informations. Next comes to the candidate key. What is candidate? Coming back to this example, here ABC is also super key, AB is also super key, and A is also a super key. Here all of 3 is the super key. Now coming to the concept of candidate key. What is candidate key? Here, listen carefully. With the help of A, B and C, I can fetch the value of A, B, C, D. In this information, these information I already have. Okay. So only I am fetching attribute D. Now coming to the A and B. With the help of A and B, I can fetch the value of A, B, C, D. If you can it is clearly seen that C is not necessary here. If I do not have C in my super key, I can also fetch the value of other remaining attributes. Now coming to the next one, A. With the help of A, I can fetch the value of A, B, C, D. So it is clearly seen that in all 3 of the keys, A is a more efficient key. It fetch all the information very efficiently rather than from both of them. So the concept of candidate keys comes into the picture that efficient super key is known as candidate key, or one more keyword I can use, that minimal super key. Minimal super key is also known as candidate key. One more definition can be derived, that a super key will be candidate key whose proper subset is not the super key. For example, let's take this super key. Will this be candidate key? Let's check. Its proper subset AB is also a super key. So this super key could not be a candidate key because its proper subset is already a super key. Let's check for this. AB is a super key, but its proper subset A is also a super key. So AB could not be the candidate key. Now coming to the A cannot be bifurcated, so it will be a candidate key. So what is the definition of candidate key is here? A minimal super key is called a candidate key, or most efficient super key is known as the candidate key. One more definition is there: a set of minimal attributes that can identify each tuple uniquely in a given relation is called a candidate key, or whose any proper subset is not a super key is known as the candidate key. So this is the concept of candidate key. Here are some important points about the candidate key, that all the attributes in a candidate key are sufficient as well as necessary to identify each tuple uniquely. Means if A is a candidate key, that means all the attributes of a candidate key are essential to find out rest of the information. Suppose we have a candidate key like A, B, C, D. So if this is a candidate key, we cannot remove any single attribute from the candidate key. We need all the 4 attributes to find out rest of the information. So this is the meaning of this point. Next, removing any attribute from the candidate key fails in identifying each tuple uniquely. Next one, the value of candidate key must always be unique. It should be unique. The value of candidate key can never be null. It should never be null. It is possible to have multiple candidates key in a relationship. Next one, those attributes which appear in some candidate key are called prime attribute. Now, what does it mean? What is the prime attribute? Suppose we have, okay, here in this relation, we have A as candidate key. So, prime attributes are those attributes which are part of candidate key. So, here part of candidate key is A. So, A is your prime attribute. And non-prime attributes are those attributes which are not part of candidate key. So, rest attribute, skipping A, B, C, D are non-prime attributes. So, here non-prime attributes are B, C, D. So, the attributes which are the part of candidate key are known as prime attribute, and rest of the attributes are comes into the non-prime attributes. Next, let's take example number 3. Okay, let's find it out. This is a relation R with A, B, C, D, and we have two functional dependency. Let's find out the closure of B. What will be the closure of B? A, B, C, and D. Now, find out the closure of A, C, D. This will be A, B, C, D. It is clearly seen that with the help of both of them, we can uniquely identify the rest of the attributes. That means B will be a super key, A, C, D will be a super key. Both will be work as a super key because both satisfy the condition of being a super key. But coming to the candidate key, and what is the definition of candidate key? That minimal super key will be the candidate key. Here, is any proper subset of B is super key? No. This is satisfying the condition of candidate key. So, this is super key. This will also be a candidate key. Here, this is super key. Is any proper subset of ACD is super key? No. So, this will also be a candidate key. Here, both the keys are also work as candidate key. Now, coming to a point, what is the primary key? New concept is coming to the picture. What is primary key? Here, database administrator choose one key to work on it as a primary key. So, there is no definition for a primary key, just depending upon database administrator, which DBA, whichever want, can choose as a primary key. He can also choose B as a primary key or B not B, then AB, ACD. This is totally dependent on database administrator. So, this is the definition of primary key. Primary key is that candidate key which is chosen by, which is selected by database administrator for designing the database, or candidate key that the database designer implement is called as a primary key. That key is known as the primary key. Okay. So, this is the concept of super key, candidate key, and primary key. Here are some key points about the primary key. The value of primary key can never be null. It must have any value at any point of time. The value of primary key must always be unique. It should not be duplicate, because with the help of a primary key, we can find out the value of other attributes. The value of primary key can never be changed. No updation is possible in case of primary key. Once you assigned a primary key, it will never be changed. The value of primary key must be assigned when inserting the record. A record only assigned with the primary key. It will never be possible that you have inserting a record into a table and without the value of primary key. It would never be possible. Next, a relation is allowed to have only one primary key. Let's have another example. Solve this by yourself first. This is a relation R, and let's find out first of all, we have to find out super key, then we have to come for the candidate key. So, search for the super key. Is AB will be super key, A, B, C, and with the help of C, yes, we can find out the value of D. Now, closure of C is B, C, D, and A. Yes, D ka closure A and D. This is the closures of A, B, C and D. So it is clearly seen that with the help of A, B and C, we can fetch all other remaining attribute of the relation R. So AB will be the super key, will be the AB and C. D will not be work as a key because it is not satisfying the definition of key or conditions of key. And what will be the candidate key? AB. Both will be the candidate key because no any proper subset of these super key will be work as the super key. So both will work as the candidate key. Primary key, it is totally dependent upon the database administrator. Whatever he will choose, he can pick up a key and work as the primary key. He will take A, B, suppose, or C. This is totally dependent upon the database administrator who designed the database. So it is the clear concept of super key, candidate key, primary key. Next, this is a Venn diagram which clearly shows that every primary key will be candidate key. If there is a primary key, suppose A is a primary key, this will always definitely always be a candidate key, and every candidate key will be a super key. If A is a primary key, it will definitely be candidate key and it will definitely be super key. Suppose B is a candidate key, so B definitely be a super key, but there is no surety about B will be primary key or not. So this Venn diagram shows the relationship between primary key, candidate key and super key. Next, coming to the alternate key. What is the alternate key? Suppose we have two candidate keys, A and CD. Suppose we have two candidate keys. One is A, other one is CD, and database administrator pick A as primary key. So A is selected by database administrator as a primary key. So here A is selected as primary key, but CD left unimplemented, unused. So the candidate key that are left unimplemented or unused after implementing the primary key is known as alternate key. So A will be here primary key and this will be alternate key. CD will be work as an alternate key or unimplemented candidate key, also known as alternate keys. Next is what is the foreign key? Let's have an example before to understand its definition. What is foreign key? Suppose we have two schema, two tables. One is employee, other one is the department. We have these attribute employee ID, employee name, passport number, license number, SSN, department ID, department name. In both of these schema or table, department ID is common attribute, and in one table it will work as the primary key. Here employee ID is the primary key, here department ID is the primary key. So the attribute which in other table work as a primary key, in these both relation are connected relation. Employee is related to the department and department is related to the employee. Both tables are correlate with each other. So here one attribute will work as the primary key in the other attribute. So this department ID is known as the foreign key for the employee table. So let's go back to the definition. An attribute X is called a foreign key to some other attribute Y when its value are dependent on the value of attribute Y. So here we are talking about the department ID in this, according to this example. Here in the relation attribute Y is present is called reference relation, and the relation in which attribute X is present is called referencing relation. Here are some key points about the foreign key. Foreign key references the primary key of the table. Foreign key reference to the primary key of the table. The foreign key can take only those values which are present in primary key of the reference relation. Means, coming back to the example, where both the values are matched, both the department ID are same, only these values are relevant in this table. Rest of the information are not relevant to the user. Only those values are relevant to the user where department ID of employee information is equivalent to the department ID of the department. Next, foreign key can take the null value. It is permissible to take the null value. There is no restriction on a foreign key to be unique. Okay, it could be duplicate. In fact, foreign key is not unique most of the time. Reference relation may also be called as the master table or primary table, and referencing table is also called as foreign table. So this is the concept of foreign key. Next, coming to the partial key. What is the partial key? Partial key is a key using which all the records of the table cannot be identified uniquely. Now, what does it mean? If we are talking about the key concept, we are studied that it can uniquely identify the attribute. Now, the concept of partial key, what is it? Let's take an example. Okay, we have student name, mobile number and food which that student like. Suppose a student name is Aman, whose mobile number is 12345, and it would like to take a pizza. He would like to eat pizza, but it is possible that Aman may have another mobile number. It is possible one candidate can have more than one mobile number. So it will have another number 4, 5, 6, 7, 8, 9, and it will also like burger. Now, Aman may also have third mobile number. So it will be 5, and it will also like French fries. So this is the table. From this table, okay, if I am saying giving me the information where student name is equals to Aman. Here Aman is not uniquely identify a single row or a tuple. We have 3 tuples where student name is Aman. But this query can return this bunch of information related to the Aman. Okay, this query where student name is Aman can return a bunch of information having mobile number and food. So here student name is work as the partial key who not uniquely identify information, but it will revert a bunches of information where we match the information in the query. So partial key is the key using which all the records of the table cannot be uniquely identified. However, a bunch of related tuples can be selected from the table using the partial key. Next one is your composite key. It suggested with the name that composite means more than one attribute. A primary key comprising of multiple attribute and not just a single attribute is called a composite key. Suppose we have a primary key like ABC. Here we have 3 attributes. So this is called as composite key where we have more than one attribute. Next one is the unique key. Unique key is nothing, it's just a concept. So it is similar to the primary key. Unique key is a key with the following property. It is unique for all the records. Yes, because it is unique. Once assigned, its value cannot be changed. Yes, it is also about the primary key, and it may have a null value. Next one, for example, Aadhaar number. Aadhaar number is work as an unique key. Next one is your surrogate key. Surrogate key has some property. It is unique, it is updatable, and it cannot be null. It must have some value. For example, mobile number. One student can have more than one mobile number. For example, Aman have a mobile number 123, but after some time he want to change his mobile number, so he can change its 123 to 456. So A will be the surrogate key, which is updatable, but unique key is not the updatable. The very last one is your secondary key. Secondary key is requiring for the indexing purpose for better and faster searching. This is also use the concept of hashing. It is not that much important from the university point of view, but it is a concept, so you may need to know what is the secondary key. Basically, it uses the hash property for searching the data faster from the table. So that's all for today. We will see in the next video. Thank you so much.